In July 2026, Moonshot AI released Kimi K3, a 2.8 trillion parameter multimodal model. China wasn't supposed to keep producing models like this. The United States had spent years restricting its access to advanced AI chips, and Chinese AI companies had far less private capital. The gap should have been widening. Yet DeepSeek R1 had already shocked the industry in January 2025. One breakthrough could be dismissed as an exception. 18 months later, Kimi arrived. Why were Chinese companies still producing competitive AI under restrictions designed to slow them down? Because the restrictions didn't stop Chinese AI. They changed how it had to compete. Without easy access to the best chips, Chinese engineers had to solve a different problem. How do you get more AI from less computing power? Without the newest processors, Chinese labs had to be more careful with every training run. Experiments an American lab could simply try, again, became much more expensive mistakes. American frontier labs could keep adding chips. Chinese teams increasingly couldn't. So they had to squeeze more from the hardware they already had. Kimi K3 uses this approach. Only part of the model is activated for each task. Think of a company with hundreds of departments. You don't bring everyone into every meeting. You call the people who actually need to be there. The company stays large. The meeting stays small. DeepSeek pushed the same idea aggressively. The hardware shortage didn't disappear. Chinese companies started designing around it. Over time, one question became increasingly important. How much capability can we keep while using less computing power? The chip controls made advanced hardware harder to obtain. They also made efficiency a necessity much earlier. But efficiency couldn't make frontier AI cheap to build. It still consumes chips, electricity, data centers, and expensive engineering talent, often years before anyone knows whether the company will succeed. The engineers had found ways to keep building. Someone still had to pay for it. By late 2023, China's AI boom had become an expensive gamble. Dozens of companies were training foundation models. Computing bills were rising. Business models were unclear, and nobody knew which teams would survive. Around that time, a Shanghai state-backed investment team was finishing its due diligence on Minimax. One review ran late into the night. The engineers were still at their desks, model parameters moving across the screens. Minimax was burning money. There was no clear winner in China's model war. The investors put money in anyway. Shanghai's state-backed funds later continued participating in the company's financing. They talked about keeping a promising AI company in Shanghai and connecting it with the city's broader industrial ecosystem. Minimax eventually listed in Hong Kong in January 2026. Microsoft invested $1 billion in OpenAI back in 2019, years before ChatGPT became a global business. But Microsoft's payoff is closely tied to OpenAI itself. OpenAI uses Azure. Its technology feeds into Microsoft products. If OpenAI grows, Microsoft benefits directly. Shanghai can benefit even before Minimax becomes hugely profitable. If the company stays in the city, so do its engineers. Its technology can enter local industries, while startups, suppliers, and customers grow around it. Some of that value may never appear on Minimax's own income statement. Zhipu shows how far that logic can go. In late 2024, it raised 3 billion yuan in a round that included state-backed investors. More state-linked money followed from Hangzhou. Then came the 2025 numbers, about 724 million yuan in revenue and 4.72 billion yuan in net losses. The funding continued. Private investors can tolerate losses too, but eventually, the company itself has to justify the investment. For a government-backed industrial fund, keeping engineers, technology, and a local industry in the race can count as part of the return. That can keep weak companies alive longer too. Some bets will fail after burning enormous amounts of money, but failures are part of frontier research. Keeping more teams alive simply buys more attempts. The same logic extends below the model layer. Changshin Memory Technologies grew for years with state-linked backing before raising 57.92 billion yuan in its 2026 IPO. And those attempts were not starting from a blank page. At the frontier, an AI lab can spend months training a model, discover the idea doesn't work, throw it away, and start again. The public never sees most of those failures. It sees the model that finally works. Once that happens, everyone behind it learns something expensive. This can be done. Papers, open models, and finished products reveal parts of the route and show competitors which capabilities are worth chasing. The follower still has to build the model. It doesn't know the exact data, internal engineering, or every training trick, but it doesn't have to pay to discover every dead end again. DeepSeek grew up in this environment. It didn't have to prove from scratch that large models could reason, code, or handle complex instructions. Other labs had already shown that those capabilities were possible. Its engineers could focus on a narrower problem. How much of that capability could they reproduce with the hardware they actually had? China also had a large pool of engineers trained by years of building internet products at enormous scale. Once the target became visible, there were plenty of teams capable of attacking it. The United States still has an important advantage here. Someone has to discover the next capability first, and American labs continue to produce many of those breakthroughs, but every successful breakthrough makes part of the road visible. The pioneer pays for more of the wrong turns. The follower can spend more time improving the routes that survived. And at the end of that road, China had something else waiting. Hundreds of millions of people ready to use the product. Pick a normal weekday in China. At 9 in the morning, an office worker opens Dubao. He drops in a messy document, asks for a summary before a meeting, then uses it to search for information and rewrite an email. By the end of 2025, China had 602 million generative AI users. By June 2026, Dubao alone had reached 382 million monthly active users. AI doesn't stop when work ends. Quen can help someone choose a restaurant, plan a trip, book flights, or shop. AI is moving out of the chatbot window and into services people already use every day. The users are much broader than young tech workers. In a 2025 CNNIC survey, people aged 19 and under made up 33.8% of generative AI users. People over 40 accounted for roughly another quarter. In smaller Chinese cities and towns, AI penetration among older users had reached 22.9% by May 2026, and some community classes were already teaching seniors to use tools like Dubao through voice. Put hundreds of millions of people into that many different situations, and companies quickly learn what people actually use, where products fail, and what costs too much. 600 million users do not automatically make a foundation model smarter, but they create an enormous testing ground. A model can move from launch to real-world feedback almost immediately. And at that scale, one question becomes impossible to ignore. How much does every use cost? Imagine you're running customer service for a large shopping app. Every month, the AI has to answer millions of messages. You test two models. The first is the best one you can buy. On difficult questions, it is clearly better. The second makes a few more mistakes, but on ordinary requests, refunds, delivery times, product questions, the difference is small. Then, the bill arrives. At a few thousand conversations, nobody cares. At millions, it becomes a business decision. So you keep the expensive model for the difficult cases and let the cheaper one handle everything else. The cheaper model doesn't need to be the best. It only needs to be good enough for most of the work. DeepSeek made this trade-off impossible to ignore. For companies making millions of AI calls, a small difference in quality can matter less than a large difference in cost. If the cheaper model already handles most of the work, the expensive model has to justify every extra dollar. And if more companies make the same choice, the effect moves beyond one company's bill. When AI gets cheaper, the obvious result is that the same work costs less. More importantly, work that wasn't worth using AI for suddenly becomes worth it. A company that once saved AI for difficult tasks can start using it for ordinary ones. Smaller businesses can afford tools that previously only made sense at large scale. Software can call models more often because every request costs less. That creates new demand. If customers can get most of the capability for much less, expensive models have to defend their premium. Competitors cut prices, which makes even more tasks economical to automate and expands demand again. DeepSeek has already put that pressure on the market. Kimi suggests it may not stop with one company. If more Chinese models keep approaching the frontier while driving costs down, they don't need to become the world's smartest models to reshape the industry. They only need to keep making capable AI cheaper. China's AI didn't suddenly become powerful. Kimi is simply one visible result of changes that have been building for years, and it probably won't be the last. If you enjoyed this video, hit like and subscribe. And I'm curious about your own AI use. How much do you rely on AI now? Which tools do you use? And what do you actually use them for? Let me know in the comments.